Okay, so let's look at D. So you can see I have written above, if ax is equal to ay, then I can set my exponents equal to each other. The bases are the same, set the exponents equal to each other and solve. But what if the bases are not the same? Like in D, where I have a 7 and a 2. Unfortunately, to my knowledge, there's no way that I can get a 7 to look like a 2 or a 2 to look like a 7 without completely changing the problem, which we definitely don't want to do. So there's a couple more properties of logs that we've gone over in the past that we're going to use now to help us solve this problem. The first is the power rule. So we know that if I have log base a, let's say of x to the power of n, I can rewrite this by bringing the n, that exponent, down to the front of the problem and multiplying it by the log term. So it becomes n times log base a of x. So that exponent comes down in front, gets multiplied by the entire log problem. The other property that's going to help me is a cancellation property. So we know that logs and exponential functions are inverses, which means if I have a problem like this, where I have log base a of an exponential term, where the base is a to the power of x, that log base a and that a, that's the base of the exponent, they really essentially cancel each other out, and you're just left with the exponent. So you get a nice clean value. So the difference, if you notice, between this problem and this problem, or this property and that property, are here the base and the value you're taking the log of, they're the same, a and a. Here it's base a, but the value that I'm taking the exponent of is x, so I can't do this cancellation. So how do we use this? Let's take a look at D. So in D, we are going to have to decide, do I want to take log base 7 or log base 2? Because I can only do one, right? I have to do the same thing on both sides of the equation. I have to pick one. Your answer will look different depending on what you pick, but the strategy is the same. So there's not really an easy way out. If one exponent is simpler, I'd say pick the log with the harder problem, or the base with the harder exponent. But since these are kind of equally difficult, x minus 3 and x plus 2 for those exponents, it doesn't matter which we pick. So I will go with, let's just do log 7. So I'm going to take log base 7 of both sides. And the reason is, if I do something on one side of the equation, I have to do the exact same thing on the other side to make sure it's equivalent. So I'm actually going to use both these properties. On the left side of the equation, I'm going to use this property, because log base 7 and that 7 here will cancel each other out, essentially. So I'm left with x minus 3, just the exponent. On the right side of the equation, these will not cancel out, but I can take this exponent and move it down to the front. And because that exponent is x plus 2, I'm going to put parentheses around it so that I don't forget that it's distributed. The whole expression is multiplied by the log term. So I'm left with x plus 2 times log base 7 of 2. Okay. So I have an x over here, an x over there. Not simple problem to solve. And this x on the right is kind of stuck in this parentheses. So it's going to seem a little bit counterintuitive, but the way to simplify this problem is actually to distribute this term on the right. So I'm going to multiply the x times log 7 of 2. Oops. So I would get x times log base 7 of 2. And then I'm going to multiply the 2. So plus 2 times log base 7 of 2. So I've just distributed out that x plus 2 so that they both get multiplied by the log base 7 of 2. Nothing happened on the left. Okay, now, next step. I want to get the x's together. So I am going to move this x log base 7 of 2. I'm going to move it to the left side of the equation by subtracting it from both sides. So it cancels on the right. On the left, I have x minus 3 minus x log base 7 of 2. On the right, I just have 2 times log base 7 of 2. Okay, I got my x terms together, but I still have this plus 3 in the middle. So I'm going to move it to the right by adding it to both sides. So the left just becomes x minus x times log base 7 of 2. And on the right, I have 2 times log base 7 of 2 plus 3. Okay, not done yet. Gonna keep going. Keep doing some more algebra. So left side of the equation, want to get x by itself. Well, it just so happens that this term has an x in it and that term has an x in it. So what I'm going to do is actually factor out an x. So if I take an x out of the first term, I'm just left with 1. If I take an x out of the second term, I'm just left with log base 7 of 2. And my right side hasn't changed. Okay, all right, we're almost done, I promise you. Last step, to get x by itself. Since I'm multiplying x by everything that's in the parentheses here, I am going to divide by that whole term in the parentheses, the 1 minus log 7 of 2. And I do that on both sides. So those cancel out, and I'm just left with I'm left with this big ol' mess, but this big ol' mess gets a smiley face, and